Hi, I'm Adam Eisman with the Electrical Engineering Department. This is our senior design project, and this is my group member.
I am Ben Evans.
Hi, I'm Warren Chang.
And I'm Alexander Sado.
So our project is a heterogeneous swarm of robots that is used to explore a hazardous environment. And just as with the Army, you don't want to send your main general into the front lines. You want to first send the less well-equipped grunts to explore the area first. So we basically have this robot is called the Grunt, and it's less processing power, less expensive grunt that is used to explore an area to make sure that it's safe for a more expensive, more sophisticated general to go in and investigate first. And we have a suite of sensors on the robots. This is an ultrasonic sensor mounted on a servo that is able to scan the environment directly in front of it as a vision, basically, to see what obstacles are near it. It has bump sensors to figure out if it bumps into something. It also has an optical mouse mounted on it to track how far it goes. And it basically has this Bluetooth connection. Each of them have a Bluetooth connection that connects back to the general. The general issues commands to each of them individually. They respond to those commands and start mapping out the environment. And then the sensor data is collected back on the general to make a map of the area to show where the obstacles are and to show what concentrations of sensor readings it gets throughout the environment. And we have mounted on here right now a chemical sensor that detects the volatile organic compounds in the air. And that could easily be swapped out with a Geiger counter for a nuclear disaster or a smoke and temperature sensor for a fire. And so basically this is supposed to map out a room quickly and efficiently while minimizing the costs and the risk associated with people. So there's a digital compass mounted right there that gives it a heading. There's the ultrasonic sensor mounted on a servo that gives it a scan of a sweep of the obstacles in front of it. There is the volatile organic compound sensor that determines the concentration of chemicals in the air. There's the Bluetooth connection that relays back to the general all of the data that this collected. The general, in addition, also has the mouse, the volatile organic compound sensor, the compass, and additional 2 webcams that are used for stereo vision that enables it. There's a lot of possibilities with that we are working on implementing right now, where it can get 3D models of a room, it can track where the grunts are. And basically, we also have the Intel computer board that has a Wi-Fi router on it that you're able to remote desktop into.
All right, so like Adam was saying, basically we have a Intel Tunnel Creek board on our general, and basically it has the processing power and capabilities of a laptop essentially. It has 4 USB hubs, and basically what we use that for is to connect to our USB cameras in order to do our disparity mapping. So like I said before, this is like a computer basically, and the issue is that you can't put a VGA screen on top. So what we do is we use something called remote desktoping, which is basically we communicate to our board through a Wi-Fi connection. And so by remote desktoping, we actually get access to our user interface right here, and this is how we issue all the commands to our grunts and also to our general. And yeah, I think.
And all right, so he did mention disparity maps. That's like part of stereo vision, and so we did a lot of video processing with this machine. As you can see, we have like the 2 webcams over here, which are used to collect our video data when general drives around the room. And from that video data, we're able to utilize a library called OpenCV, which we build on Open Frameworks. It's like a C++ library that comes with a lot of functions to process videos. And what we actually do with that is with the 2 cameras, we collect like a left and right image, and then through some algorithms are able to come up with a disparity map, which basically is a representation of the depth of the room. And so with that, you can know exactly where different things are located, reference from the general or wherever the camera is mounted on. And so we've been able to get depth maps, disparity maps using the webcams, but then it does have a lot of possibilities from like different future research, I guess. We can like build like 3D models of a room and even reconstruct a map of the room in 3D. So like it's really exciting, and as you can see, it is like an example of the occupancy grid that can be built with the OpenCV. So I think I'll pass it back to Adam to just conclude.
So the grunts know how far they traveled, but they don't know where they start from. The optical mouse basically tracks, just like as you use it on a screen on a computer, it tracks how much ground has moved underneath it. So they have to start from a known position and orientation, which is why we have these deployment ramps on our general. And so we know that this grunt starts right here. We know from the mouse data how far it travels, and we're able to then track it throughout the room based on the mouse data and the compass heading data. And so once these drive off, we then fold up these ramps. The general is more maneuverable. So once the grunts deploy from the general, we can then fold up these deployment ramps. The general becomes much smaller, able to fit in smaller places and maneuver easily throughout the room.